Hi, welcome in our sixth video in our series on naming organic compounds. In this video, we're going to focus on how exactly we find and name the longest carbon chain inside the organic compound. Now, this series of videos was made with the Eden and Central Karoo Education District teachers and subject advisors that work together to bring you material for revision or for use in class on the grade 12 physical science CAPS curriculum. We are busy with naming organic compounds, and we said the way that we are going to handle this is to start from the back of the organic compound and work to the front of the name. So in our first 4 videos, we focused on how exactly to identify the homologous series. Then in the next video, we said that we need to identify the position of the functional group. In this video, we are going to look at this part of our organic compound's name. This part tells us exactly how much carbons we can find in the main carbon chain. Now, what do I mean by that? Let's look at it this way. If in my carbon chain I only have one carbon, then I'm going to use the prefix me. What does that mean? A carbon or an organic compound with one carbon can be something like methane, methanol, methanol. You know by now that methane must be an alkane that only contains single bonds. Methanol is an alcohol that where the OH that contains the OH is the functional group. But now you also know from this video that methanol will only have one carbon in its main chain. Methanol, you know by now the Al tells me that it is an aldehyde containing one carbon. If I have 2 carbons in my main chain, I use the prefix et. Examples: ethane, ethene, ethyne, ethanol, and so on. For 3 carbons, I use prop. Examples: propane, propene, propanol. For 4 carbons, I use but, butane, butanol, etc. You must know the first 5 or the first 8 prefixes. For 5 carbons, I have pent as a prefix, pentanol. What does this mean in this whole name? There is my functional group. There is my homologous series, the alcohols. There is the position of my functional group. It is on the second carbon that I find the OH, which is my functional group. And this pentan will tell me now in the main chain I have 5 carbon chains. For 6 carbons, I said carbon chains, I mean carbon atoms. For 6 carbon atoms, I will use the prefix hex, for 7 hept, and for 8 oct. And examples of each of these are included here. I suggest if you don't know these prefixes, now is a very good time to pause this video for a small while and just try to memorize them. Me tells me there's 1. Et, like in ethane, tells me there's 2. Props 3. 4 is bute. Pent is 5. Hex is 6. Hept is 7. And oct are 8. Now let's look at a couple of examples. Okay, so what can we tell from the videos at this stage? If I look at this organic compound, I can see the functional group here is the OH, so I immediately know this is an alcohol. There's only 1 carbon in the main chain, which tells me that it has the prefix me, which means this entire thing must be methanol. If I look at my second example over here, I see there's only single bonds, which tells me it's an alkane. In this alkane, I know that I don't have to identify the position of the functional group, so I'm not going to have any numbers. I've got 2 carbons, so this one will be called ethane for the 2 carbons. Now what do I have here? Can you see I have a double bond, which tells me it's an ene. Now, the interesting thing with this specific carbon organic compound is that actually the double bond cannot be on any other place than the first carbon. If I place the double bond over here, then I would just number the series from this side, because remember, my functional group must always be on the carbon with the lowest number. So I know I'm going to end with ene because I've got a double bond, which means it's an alkene. I know that I'm not going to need to identify my functional group for this one because it cannot be on any other place than on the last one. And I know that I've got 3 carbons, so I need to use the prefix prop, which means that the name of this thing will be propene. Let's look at our next example. Which functional group do I have here? I have a haloalkane because I have a halogen there that is connected to an alkane. So in this case it's going to end with ane, I know, and somewhere in my name I'm going to have a chloro. The second thing that I know is that that chloro is on the first carbon. That's the position of my functional group. Now the haloalkanes is a bit dicey and a bit tricky because the chloro part actually interferes with our recipe, starting always from the back. The halogens will be somewhere in front with the other side chains, but we'll get to that a little bit later. This is one of those little exceptions to the rule. But we see in this whole chain we've got 4 carbons. So this will definitely be a butane, and in fact the name of this thing will be 1-chlorobutane, which tells me that the chlorine is on the first carbon and the main chain consists of 4 carbons. In our next example, what do we have here? We have a double bond O, which is in the middle of the carbon chain, which tells us that this is a ketone. In this ketone, because it's a ketone, we know it's going to end with -one. So what is the position of the functional group? Well, let's see. There's my carbons. I can either number 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5. If I number from this side, it means my functional group is on the second carbon. So this means I'm going to have a 2-one because the carbon is on the lowest one. And in my carbon chain, how many carbons do I have? 1, 2, 3, 4, 5. The prefix for 5 is pent. So I know the name of this example is going to be pentan 2-one. Let's look at another one. To which homologous series does this belong? I've got a double bond O right at the end, telling me that this whole thing must be an aldehyde. So it's going to end with -al. The aldehydes, I don't have to specify the position of the functional group. So I'm not going to use a number. Why? Because the position is always going to be right at the end. The next thing that I need to identify is how many carbons I've got. 1, 2, 3, 4, 5, 6. 6 carbons. I know I'm going to use the prefix hex. So the name for this compound is hexanol. And then my last example for today, what do we have here? Double bond O with the OH tells me that I'm dealing with a carboxylic acid, which will end with enoic acid. Again, the carboxylic acid, the functional group is always on the same place, always at the end or the beginning of a chain. So I don't have to indicate the functional group with a number. So let's see how many carbons I've got in the chain. It's 1, 2, 3, 4, 5, 6, 7. I guess it's more appropriate to number from this side. 1, 2, 3, 4, 5, 6, 7. 7 tells me I'm using the prefix hept. So this is going to be heptanoic acid. Enoic acid tells me that I'm dealing with a carboxylic acid. I hope these 7 examples gave you a good idea of how to name these compounds. In our following quiz, I'm going to require you to write down the names, and in those names you will have to identify the type of homologous series that we have, the position of the functional group, as well as the amount of carbons in the main chain. Good luck!